Okay, let's just look at the second example here, 9b. Okay, so what you have to do is you have to factor out here. Okay, you have to factor out the x squared from the denominator. Okay, if you factor out the x squared from the denominator, so you see that you will have x squared here. Okay, and if you factor x squared from here, so you basically will have x. Okay, and factor out x squared from here, so you have plus 2. Right, so that is the rational function after you have factored out the x squared. After you have factored out the x squared, the next thing that you should do is you have to do the decomposition. So let's just do the decomposition. Okay, try to write out the thing that you factorized just now. Okay, so for this type of the rational function, okay, you will have two methods to decompose. Okay, so you will come across option 1, you come across option 2, but the option 1 will be the better one, the better option. Okay, where the option 1 is basically try to consider the x squared as linear. Okay, you just consider the x as linear, and it has been repeated for 2 times. Okay, so it's repeated for 2 times. Okay, if you consider that way, it means that your rational function will become you have x, one linear here, and you have another linear x, but it's until the highest power of the linear function is power of 2. So this is linear, and this is also linear. Okay, we consider all of them is actually x. Okay, but it's repeated until x power 2. All right, okay, and we have another fractions that is coming from x plus 2. Okay, so since that we consider this one as linear function, on the top should be constant, so that it will be your a, and this is also constant, it will be your b, and this is also constant, so this will be c. Okay, so because all of them we consider them as linear. All right, okay, so when you do that, okay, the next thing that is you have to multiply each of the thing that you see in here with factors. Okay, with some factors. Multiply each item with factors. Okay, with what factors? With this factor. With these factors, that is x squared, and without the brackets. That is x squared, x plus 2. Just multiply whatever that you see at the left, the denominator. Okay, at the left, this is the left hand side, this is the right hand side, so the denominator of the left hand side becomes the factor. Okay, become the factor. Once you have this factor, so multiply each thing that you see here with this factor. Okay, so if we multiply this fraction with this factor, obviously x squared cancel out, x plus 2 cancel out, so you have 2x minus 6 at the left. Okay, at the right hand side we have the first fraction, so these first fractions multiply with this. Okay, so when you multiply this fraction with this, okay, this x and x squared can be cancelled. You cancel, so you have x plus 1 and this. So of course the a you have to write it. You multiply this fraction with here, and this cancel, so remaining of x and x plus 2. Right? Okay. Then what happened to the next? Okay, so multiply this fraction with this. Okay, so if you multiply this fraction with this, okay, so x squared and x squared can be cancelled. So what is remaining? Well, the remaining thing that is b and x plus. Okay, so we have b, and the over x squared already cancel out with this, so you remaining of x squared plus 2. Okay, and then the c. Okay, the c here. Okay, this item multiply with this. When this item multiply with this, the x plus 2 can cancel out with x plus 2 here. So when you cancel out, the thing that remain is x squared. Alright, okay, so you can leave it this way, or you may expand this to another line, okay, but usually I will leave it, okay. I'm going to compare the left hand side and right hand side directly, okay. So let's just compare left and right. Okay, so let's just check the highest power that you can see in the left and in the right. In the left, you have the highest power that is power 1. Okay, in the right, you have the highest power that is power 2. Okay, so you're going to begin with the highest power, that is your x squared. Doesn't matter it's coming from the left hand side or the right hand side, but just take the highest power that you can see from the equation. Okay, so okay, let's just compare x squared first. Okay, we're going to take the value in front of the x squared. So let's just look at the left hand side. For the left hand side, do you see x squared here? No, we see we do not have the x squared. So where we do not have the x squared at the left hand side, so we consider we are having a 0x squared, or and a 0x squared, so we have a 0x squared here for the left hand side. For the right hand side, this is the right hand side, okay, of the equations. Okay, for the right hand side, if you expand this, you will see ax squared. But we are interested to know the value. Okay, so we just write a. Instead of ax squared, you write a. So, okay, we look for another x squared. Here, you can see that is, yeah, we have plus c x squared. Okay, we are interested to know the value. Okay, the value of x squared, that is c. So, we write plus c. Instead of plus cx, you write plus c only. So, that is the first equation that you can form from comparing. Okay, so the second line that you're going to do is you're going to write x. Okay, you're going to compare the value for the x. Okay, or the coefficients for the x. Okay, for the left hand side, the coefficient of the x is obviously 2. So 2x. Instead of writing 2x, you write 2. Okay, how about the right hand side? So right hand side, let's see. If you expand this, so you have 2ax. 2ax. Okay, so instead of writing 2x, you're going to write 2a. Okay, how about the next? We have bx here. So instead of writing bx, you can write b. We're just interested to know the coefficient or the value in front of the x. Okay, so that is for the second equation for comparing. Okay, so then we're going to look at the constant. So let's look at the constant. Okay, in the constant, for the left hand side, we have minus 6. And in here, where is the constant? In here, we have another constant that is 2b. So you expand this, you have 2b. Alright, okay. That is the result of comparing, okay? And we need to solve. We need to solve those equations that we obtain from comparison, okay? So if you solve this one is basically give you b equal to minus 3, okay? Once you know your b is minus 3, you can get your a from the equation 2. So try to sub the b as minus 3 into your equation 2. So equation 2 that we have 2 equal to 2a plus, okay, b. The b here is minus 3. Okay, so in here, okay, you solve it. So you bring this one to the left hand side. We have 5 and 2a, and a is actually 5. over 2. Okay, once you know your A is 5 over 2, so try to sub this 5 over 2 into number 1. Okay, then you will get your C. So sub your A as 5 over 2 into number 1. Okay, so we have 0 here, and it's 5 over 2 plus C, and you know that your C is minus 5 over 2. Okay, now we have our answer of the A, of B, of C. So what are we going to do with those values? Okay, so let's just check back. Okay, I'll have to push it to the left a bit. Okay, let's just look at the thing that we did just now. Okay, so we say that, okay, you decompose it to a general form. Okay, the general form, okay, that is AOX, BOX squared, and plus C over x plus 2. Okay, so you got the value of A, B, C. Just sub it here. Substitute into here. So you substitute. Okay, let's see what happens if you substitute. Right? Okay. Oh, yeah. Yes. Okay, we says that, okay, initially this is a general form. Okay, we're going to substitute. So you're going to have 2x minus 6. This one is x squared, x plus 2 equals to, okay, what is your A? Your A is 5 over 2. So that is 5 over 2. That is your A. And don't forget to write back the x. You have the x here. It's over x, right? The A is 5 over 2. Just write it that way. Okay. And we have the next, that is your B. Your B is minus 3. So minus 3 over, then we have the x squared. So let's write the x squared here, x squared. Okay, and then plus, okay, sorry. Okay, this is the x squared, and this minus 3 is coming from the B, okay. And the value for C, that is minus 5 over 2. Just write minus 5 over 2. Okay, and this x plus 2. So this is the value of C, and this is x plus 2, x plus 2 here. So this is the last line that you get for the decompositions. Okay, once we have the last line of the decompositions, now we're going to do the integration part. So back to the questions. We have not finished yet. Okay, back to the question. Okay, I'm going to place it back here. So just now we say that, okay, after we have integrated, we have did a long way, okay, to do the decomposition, we say that this one is equal to this. So the next thing that you should do is sub this one to this item. So we will have integrations of 5 over 2x minus 3 over x squared minus 5 over 2x plus 2 dx. Okay, so once I had that, okay, this one can delete it. Alright, okay. Okay, so so before we integrate, okay, you can think of this one as 5 over 2 integrate of 1 over x dx, and this one is minus 3 1 over x squared dx, and this one is minus 5 over 2 integrations of 1 over x squared x plus 2 dx. Alright, okay. So of course this one you have the direct integration formula, and this one also you have, and this one is actually you can change it to the index before you integrate. Okay, this one if you integrate, it will give you ln x. Okay, so for this you can change it. Okay, so change it to x minus 2. Okay, this one we did not do any integration yet. Okay, because you have to change to the index before you do the integration. Okay, and then we have this one you can integrate. This one you integrate. If you integrate, we will have ln. Okay, we will have this is x power 1, right? So we have ln x plus 2. Okay, because we cannot write the C first because this is not finished yet. So let's just finish it. Okay, so from here. Okay, so for this, if you integrate, okay, you will have x minus 1 over minus 1. And this will be the same. Okay, and simplify it. So simplify it, we will have 5 over 2 ln x. Okay, this is plus 3. X minus 1, that is over x. Alright, so the final answer should have plus c. So this is the final answer for this example.